Now we see the combination of both elements. For example, I'll start with R and series circuit. Next, I'll go with RC series circuit. Okay, later on we are going to discuss with respect to parallel circuits. Okay, right. So, which are very important as per the AC circuits are concerned. Okay, my dear students. Now, for example, if I take R and series circuits, so therefore just draw the circuit first. This is a resistor and this is an inductor. This is R and this is L. Okay, right. Now let me subject AC source to this combination of the circuit. AC source to the combination of the circuit. That is V of t, and the current flowing through is nothing but I of t. Let me assume like this. Right. So here the voltage across the resistor is VR. The voltage across the inductor is VL. Let me write the point. VR means voltage across resistor. Similarly, VL means voltage across inductor. Okay, so here inductor and resistors are connected in series. Got it? So meaning is what? As per the series connection is concerned, what is the basic knowledge we need to have? The basic knowledge we need to have is that in series connection, the voltage is going to be divided, and similarly the value of the current flowing through the resistor and inductor will remain as same. Meaning in series the current will remain same, but as per the voltage is concerned, it is going to be divided. This is the basic information we should have whenever we discuss about series circuit. Right, my dear students. Now, let us see some more points which are related to the series connection. Right. So here, as per by KVL, if I say by KVL, you know that how we apply the KVL. There is nothing but the voltage range is the sum of the voltage ranges is equals to sum of the voltage drops. Right. So therefore, if I write like this, that is voltage V is nothing but the voltage is supplied is equals to VR is nothing but the voltage across the resistor plus VL. VL means the voltage across the inductor. This is the general format what we write to represent the KVL. But the point here is that whenever you write an equation here in terms of AC circuit, you should remember the phasor relation between the voltage and currents. So here, just observe here. What is the phase angle between the voltage across the resistor and current through the resistor? It is nothing but 0 degrees. How much angle? That is nothing but 0 degrees. Of course, this is called as polar form, which is a mathematical representation. Similarly, if we observe the voltage across the inductor and current through the inductor, always remember inductor leads the current by an angle 90 degrees. That is the point what we have discussed in the previous session. Right. So here voltage leads. Leads means what? Plus. How much it leads? 90 degrees. So plus 90 degrees I have mentioned. Clear? Now let us write this equation once again. V is equals to VR at an angle of 0 degrees plus VL at an angle of plus 90 degrees. Got it? Right. Now what I do here is I just divide on both right hand and left hand side to make the equation to be remain the same by a current value of I. The same parameter on the right hand and left hand side. So we don't have any change in the equation, correct? So V upon I will represent as Z, that is equals to VR by I is nothing but what, my dear students? R. Here the parameter is plus, I'll put a plus. J. So here J means I'll just represent, J is represented by what? It represents what angle? 90 degrees. So here 90 degrees I'll represent it as what, my dear students? J, and VL by I is nothing but XL. Understand? Remember this expression, which is very important. Understand? Whenever you discuss the concept of AC, Z will comes into picture. You cannot avoid Z. You cannot avoid this Z whenever you discuss an AC circuit. Okay? If any question asked in AC circuit, that question must directly or indirectly related to this particular Z. Sir, what is this Z called? Let us have a new introductive parameter for the given circuit expression is nothing but a Z. Sir, what is this Z is called as? So my dear students, here a new parameter that is given Z is called as impedance. It is nothing but what? Impedance. Remember this point. Z is nothing but what? Impedance. Okay, sir, what is this Z? Z is nothing but voltage upon current. Simply, I could write like this also, my dear students. That is voltage phasor, the ratio of voltage phasor. Phasor means with respect to some angle upon current phasor. Current phasor. Okay, volt upon amperes is nothing but the units will remain as what, my dear students? It remains as ohms. It remains as ohms. Got it? It remains as ohms. Okay. Now, sir, what is the Z expression for the RL series circuit? Z is equals to R plus J times of XL. This is the expression you should remember throughout your lifetime whenever you discuss about AC circuits. Clear? Right. So here R is a resistance. I repeat the point here. V upon I is nothing but Z, where V upon I means what? The voltage phasor upon current phasor is nothing but the definition of impedance. So here VR by I means R we know, VL by I means XL we know, just we have seen pure inductor and pure resistor, right? So, and here sir, why you have placed plus here? Plus means plus here, plus I just placed, and 90 degrees represents the J. So J 90 degrees replaced by J, plus means leading means I just put here plus, that's it. Okay, this is the expression for Z. Okay, now sir, what is the observation here? For just observe here, for RL series circuit, imaginary, that means the J will be always remains as positive. I could say like this, J is positive. J plus J na, so J is positive. Remember this point. And similarly here R is nothing but what? A resistance, and I could say it is nothing but a real part. What is it? It is a real part. And here you can observe what is this XL, J times of XL. It is nothing but imaginary part. Imaginary part. So what is the point you need to remember is that, my dear students, see, real part always considered to be positive, but imaginary part you can consider positive or negative. Both are positive. Both are possible. Okay, so this part of real part is always remains as positive, but this part might be negative or might be positive. This is the should be remembered, right? So next I would like to have an expression for this Z as like this. See, I'll write like this. That is impedance triangle. Impedance triangle. Let me discuss about this impedance in a different way. That is called as impedance triangle. Sir, what is this impedance triangle could be represented? So here I just drawn the impedance triangle something like this. Correct? So this is an impedance triangle. Let me have this as a triangle, and what I am writing here is nothing but this is resistor, and this is the part of XL, and this is nothing but Z, and this is the phase angle phi. This is nothing but phase angle phi. Understand? Sir, where this phase angle comes from? Yeah, just go with this. Just observe here. So let me have, just observe here. If I draw the phasor diagram, just observe here. As per the series is concerned, the current will remains constant. Yes, of course, this is the current which remains constant. Next, as per the inductor resistor is concerned, just observe here. One is 0 degrees, one is 90 degrees. Correct? Just according to that means the resistance is having the voltage and current in phase. Similarly, as per the inductor is concerned, the voltage across the inductor must leads the current by an angle 90 degrees. That is what we have seen. And what would be the resultant of this? What would be the resultant of these two voltages? The resultant of these two voltages I could represent like this. This is the resultant voltage. This is the resultant voltage, or I could say the total supply voltage V. Understand what is this angle? This angle is nothing but phase angle phi. Understand? So what is the observations here is that here voltage V leads current I by an angle phi. Before, whenever the pure inductor I said it was 90 degrees, and whenever I say the pure resistor it is 0 degrees. But here the angle, that is nothing but, if I write in terms of current, I could write like this: I current I lags V by an angle phi. That means simply I could say one point. What is that? Phi must be less than 90 degrees. Phi must be greater than 0. Means greater than 0 degrees, less than 90 degrees. When I say pure inductor, equal to 90 degrees. When I say pure resistor, equal to 0 degrees. But here I have taken resistor and inductor. So therefore, the phi must lies between 0 and 90 degrees. Okay. You can observe this phi. This phi is greater than 0 degrees, less than 90 degrees. Okay. And similarly, I could say one more expression for this also. What is this angle would be? This angle is how much? This angle is 90 degrees minus phi. 90 degrees minus phi. So therefore, I could add a point for that. That is nothing but voltage V means total voltage lags VL by how much angle? 90 degrees minus phi. Remember this one, which is very important. So you can observe here as the vector rotates in this direction. Therefore, supply voltage. What is V here? V is nothing but total supply voltage. VL is nothing but voltage across the inductor. VR is nothing but voltage across the resistor. And this is the current which remains same. In series circuit, the current will remain same, such that I have taken for the reference as a phasor diagram. So for the phasor diagram, I have taken current as a reference, right? So here, next if I go with the power factor. So power factor, that is nothing but power factor I would represent it by cos phi. Therefore, simply I could say that power factor, or I could say it is nothing but cos phi. So if phi lies between 0 and 90 degrees, then cos phi lies between 1 and greater than 0. If I say 0, it is nothing but ZPF lagging. If I say 1, it is nothing but pure resistor. Clear my point? So the power factor lies between 1 and 0, means less than 1 and greater than 0. Okay, like this I could represent the power factor. Okay, so now let us have few more points from here. As I said before that from this phasor diagram, we can have the observations like this. Okay. So what is observations here? Just point 1, 2, 3, just go on just mentioning it. So the total voltage, V is the total voltage, I is the total current to the circuit, and the phi is the angle between the voltage and current. Similarly, here voltage leads, or I can say current lags the voltage by an angle phi. Next point. The angle between VL and V. What is VL? Voltage across the inductor. And what is V? V is nothing but total supply voltage to the circuit. So the angle between total supply voltage and as well as the voltage across the inductor is nothing but 90 degrees minus phi. This is the bit question in general many times asked in the previous year examinations. Okay, now from this right angle triangle, just observe this right angle triangle. This is the right angle triangle, I could say, right? So from this I could have voltage triangle. Then let me write it as voltage triangle. If I say voltage triangle, then what I can write from here? The voltage triangle will be looks like this now. This is nothing but what? Voltage V, and this is nothing but VR, and this voltage is nothing but what? VL. This is nothing but phi. So observe here, this is a right angle triangle which I have taken with respect to phi. This is adjacent, length is nothing but VR, and this length is nothing but equals to this one, that is VL, and this is the length is nothing but equals to V. So I could have a right angle triangle which looks like this. Point number 1. Right. So sir, from here what type of questions they would ask? That means they would ask, first point to be remember, that is magnitude. Magnitude. So magnitude means from Pythagoras. From Pythagoras, I could write like this. V square is equals to VR square plus VL square. From Pythagoras, I could write V square is equal to VR square plus VL square, where hypotenuse square is equals to sum of the sides square. Okay, right. So therefore, V is equals to, I said it is a magnitude, under root of VR square plus VL square. Similarly, next point number 2, if I ask phase angle. Phase angle. Sir, how can we calculate this phase angle? That is calculated by tan phi is equals to, tan in the sense what, my dear students? Opposite by adjacent. Therefore, VL upon VR. VL upon VR. I could write VL upon VR. So, what is the phase angle phi? That is equals to tan inverse of the ratio of VL upon VR. Like this, I could represent the phase angle phi. Right. Now, let us go with the third point to be remembered, which is also very important. That is nothing but power factor. So, if I ask what is power factor, then that could be represented by cos of the function phi, which is equals to what, from the right angle triangle. If I ask what is the cos function, you can write with respect to an angle phi, that is nothing but adjacent upon hypotenuse. That is written by VR upon V. Understand? So like this you can represent it as, or you can say this is nothing but what, my dear students, magnitude na. So VR upon the magnitude, you can write it as what? VR square plus VL square. And here the power factor leading or lagging, the power factor must be lagging. Why sir lagging? Because here the current is lagging. Say sir, no? You can observe this current. Current is nothing but what, my dear students? It is nothing but lagging. So as the current is lagging in the sense, the power factor must be lagging. So remember this point. So whenever a question is asked in AC circuit with respect to RL or RC circuit, then the question must be related to the magnitude, related to the phase angle, related to the power factor. That's it. Okay, right. Remember these basic steps. Now let us observe here what I got from here. That means what is the relation I got from here with respect to the voltages? Just observe here. As I said that the voltage which I have written is nothing but like this now. That is nothing but what? V, and this is V. And this is V, and this is nothing but what, my dear student? This is nothing but VL, and this is VR, and this is phi. As I said, correct my point, right? Now what I do here is, let me divide this V by I and V by I and V by I. Therefore, does we have any change in equation? No change in equation. Therefore, this particular diagram I could represent it by like this. I could represent it by like this. Just observe here. I could represent it by like this, where I could replace V by I, it is nothing but equals to Z, VL by I, which is equals to XL, VR by I is equals to R, and the phase angle remains as phi. Understand? And this right angle triangle is called as impedance triangle. This right angle triangle is called as what, my dear students? Impedance triangle. Right? Sir, what would we have the relations? Yeah, of course, again we go with the things which we have done previously. There is nothing but what? A magnitude. First one is what, my dear students? Magnitude. From Pythagoras, Z square is equals to R square plus XL square, where Z magnitude is equals to under root of R square plus XL square. That's it. Similarly, next point is what, my dear students? Phase angle. Next one is what, my dear students? Phase angle. Okay. If I go with phase angle could be written as what, my dear students? There is nothing but tan phi is equals to opposite upon resistance. Means opposite upon adjacent. Adjacent is nothing but what? Resistance. Therefore, phi is equal to what I can write here? Tan inverse of XL by R. This is the phi. Next, what my dear students? That is nothing but power factor. Next, this is the first one to be understood. This was the second one to be understood. And the third one is nothing but what? Power factor. If I write the power factor is what means? The power factor is nothing but cos of this function phi. So therefore cos phi is equal to, cos in the sense what? Adjacent upon hypotenuse, that is nothing but r upon z, where the z must be its magnitude. Therefore r upon under root of r square plus xl square. Lagging or leading? Why? Because the current is lagging, therefore the power factor must be lagging. Remember this relation, which is very important for the exam. Okay, right. Like this we are going to have the questions based on magnitude, based on phase angle, based on power factor. This point should be remembered, which is very important. Okay, like this we are going to have impedance triangle. Okay, and this is nothing but voltage triangle. Okay, my dear students, remember these 2 points which are very important. Okay, right. Sir, now I would like to have a justification. What the justification is that? Remembering point. Okay, sir, as per the power factor is concerned, I got 2 relations. Power factor is concerned, I got 2 relations. One is cos phi is equals to, see here, cos phi is equal to what? VR by V. That is nothing but VR upon V. Yes, of course. Similarly, the power factor is equal to what I got relation? R upon Z. Correct my point? And what is it is? Lag. Understand? So my dear student, this is very important relations to understand, is that as per the power factor is concerned, we are going to have a relation with respect to voltage and resistance and inductance is given by like this. Therefore, for a RL series circuit, the power factor could be defined as the ratio of voltage across the resistor to the total supply voltage, and resistance to the impedance is nothing but which is lagging. Understand? So like this also I can define the power factor. The ratio of VR upon V or R upon Z is also power factor, and the current is lagging for RL series circuit, therefore the power factor must be lag. Okay, like this we are going to define this impedance and as well as voltage triangle, where it comes from the phasor diagram. So this is about RL series circuit. Now my question is, sir, if RL series circuit is there, therefore does we have any power factor, sir? Yes, of course. Any have power factor means we have any power factors? Yes, is there. But we write the average power for this circuit. For example, average power is equals to, we write it as what, my dear students? VRMS into IRMS into cos phi. VRMS into IRMS into cos phi. So this is the average power what we got. Understand? Sir, why we have written cos phi, sir? Because the cos phi is not even 1, cos phi not even equal to 0, but it lies between 0 and 1. Therefore, there exists a power factor such that the relation of average power could be given by VRMS into IRMS into cos phi. And the units which remains as what, my dear student? That remains as watts. That remains as watts. Understand? Remember this expression. Understand? Remember this expression for the understanding of what would be the power. Okay. Now similarly, sir, does we have any other powers? Yes, of course. There is a one more power, that is nothing but reactive power, which is nothing but VRMS into IRMS of sin phi. We can write like this. Understand? And this is nothing but what? Volt ampere reactive. And here there is an apparent power, S is equals to VRMS into IRMS. This is the apparent power. So what should I remember? What should you remember, my dear students? You should remember the relation of this particular powers and their units, volt ampere. Understand? So this is average power. I could say this is nothing but what here? It is nothing but average power or active power or true power. Okay. And similarly, if you ask, this is nothing but reactive power, and this is called as apparent power. This is nothing but what? Apparent power. Got it? This is nothing but apparent power. You should remember this. Right. And I will discuss this. This power discussion has been done in our basic levels. So go back to this relation how this powers has been discussed. Okay. But for this instant, remember these powers to be existed. Okay. So this is about RL series circuit.
గ్రేట్ ఇన్స్టిట్యూట్ యాప్ని ప్లే స్టోర్ నుంచి డౌన్లోడ్ చేసుకోండి. ఆర్ఆర్బి ఎన్టీపీసీ, సో ఏఎల్పి సిబిటి2 అండ్ గ్రూప్ డి క్లాసెస్ ఎవ్రీ మండే దిల్సుఖ్ నగర్ అండ్ సికింద్రాబాద్లో బ్యాచెస్ స్టార్ట్ అవుతాయి.